Okay, so throughout this course we're going to be always referring back to this concept called Boolean Algebra. Boolean Algebra is the study of algebra of a Boolean valued expression. So you have some sort of expression, it might be a mathematical formula or it might be a statement in English, and with these statements take on Boolean values. So when I mean a Boolean value is either true or false. So the word Boolean alone means true or false. And we can express statements in Boolean algebra, and a wonderful property of these expressions is that they're unambiguous, unlike plain English, which has plenty of ambiguities. So I want to go through some examples of some ambiguities. So for example, suppose you're at a cafe and you ask the waiter, I'd like some tea and coffee with sugar. There's really two ways he could interpret this. He could interpret this as, I'd like some tea and coffee with sugar. That is, you would like a mug of tea with sugar in it and a mug of coffee with sugar in it. Or he might interpret it as, I'd like some tea and coffee with sugar. That is, I'd like a serving of tea with no sugar in it and a serving of coffee with sugar in it. And so already we can see that these statements are ambiguous, even though this is a completely syntactically correct statement. It's still ambiguous, right? And these ambiguities can end up costing a lot of money when there's big problems as cause a result. So if we could more formally state this sentence in a system where we can't have ambiguities, that would be really useful, and that's part of what Boolean algebra does. A more nonsensical example would be the sentence, fruit flies like butter. And so there's two ways to interpret this. You can interpret it as fruit flies, and this isn't like the insect fruit flies, beg your pardon, they like butter. So it could be something like this. Here are the fruit flies and they like butter. Or it could be possibly the more nonsensical interpretation, fruit flies like butter. That is, if I throw a piece of fruit, it flies just like if I threw a block of butter. I mean, probably from context you'd work out this is what I really meant, not this. But for other examples that aren't so nonsensical, these ambiguities can cause all sorts of problems. So in later videos we'll go through examples of how to take a statement in English and write it in Boolean logic and vice versa. But we'll go through some simple examples first. So a Boolean expression is usually called a predicate or a statement. So these two sentences here, these would be, I guess the first one would not be a predicate. I'd like some tea and coffee with sugar. Well, I guess you could interpret that as a predicate. I guess it'd be a true statement. If it's true that I did really like some tea and coffee with sugar, then it'd be a true statement. And then fruit flies like butter. Well, again, this is either going to be true or false. Either the fruit flies either like the butter or they don't. This statement here is either a truth or it's a lie, right? And so statements that are either true or false, we call them predicates. So here I've got some example predicates. I'd like you to just pause the video for a moment and then go through and sort of mentally check off which one of these sentences are a predicate, that is, they evaluate the true or false, and which one are not. Okay, so let's have a look at the first one. Banana is the best fruit. Is that true or is that false? Well, I mean, it's subjective, right? I might like bananas, but you might not, right? So unless you've got a formal definition of best, I don't believe this is a predicate. I don't believe this statement can evaluate the true or false. Maybe if you had a more useful definition of best, like banana is the best fruit, as by best being measured to, total number of fruits sold in the year, then you could ask that question, is banana the best selling fruit? That would be a predicate. So let's look at the second statement. David likes bananas. Well, it happens to be the case that I do like bananas, but even if I didn't, or even if you didn't know how much I like or dislike bananas, this is still a predicate, right? Because this statement here will evaluate to true or false. Either I do or I don't like bananas. So this is a predicate, and in fact it's a true predicate. Because I do like bananas. Okay? 7 is an even number. I mean, that doesn't sound true, but this is still a predicate, right? This statement either evaluates a true or false. So it is a predicate, and it's a false predicate. because 7 is an odd number, right? If I forget my umbrella, I'll get wet. Well, we can't really work out whether this is a true or false statement because you need a bit more context. Like if it was raining, this would probably be a true statement. If it was a bright sunny day, this would be a false statement, right? Because if you forgot your umbrella, then you wouldn't get wet. And so when we write statements like this, an if statement, this is essentially a promise that if you forget your umbrella, then I guarantee you'll get wet. And we'll talk more about so these promises, these if statements are called implications, and we'll talk more about them later on in the course. But this is indeed a predicate, but we can't really work out if it's true or not because I need more context to work that out. Banana. Well, this doesn't really evaluate to true or false regardless of content. It's not even really a valid sentence alone, so this is definitely not a predicate. And the Riemann-Zeta hypothesis is true. The Riemann-Zeta hypothesis is a hypothesis in mathematics. It's an open problem that people have been working on for a very long time. So this statement alone, the Riemann-Zeta hypothesis is true. I mean, that's certainly, this whole statement is either true or false. So it definitely is a predicate. But we don't actually know if this is a true statement or not. In fact, nobody knows if this is a true statement. It's still a predicate though. So basically, any sort of sentence that asserts something, like the sky is blue, is a predicate, whereas anything that doesn't evaluate to true or false, maybe the statement, do you like apples? This isn't a predicate because it's posing a question to the reader. This doesn't evaluate to true or false, so this would not be a predicate. Okay, so I hope you got the concept of what is a predicate, because we're going to be using the word predicate very often in this course.